we're slow learners, we're finally figuring out how to move. To do that, of course, we need wonderful faculty that can stimulate this kind of debate. On the side of the architecture school, Professor Michael Bell is really the conference chair and is the sort of curator of this event. And he's the one that's found a way to have us all think about materials differently. He works closely with our good friend and colleague, Professor Christian Meyer, of the chair of civil engineering and engineering mechanics. As I said, we started with glass, we moved on to concrete, now we're doing metal. We were going to do plastic, but maybe we better do sheetrock. We're really serious about facing the material that's all around us and nobody looks at it. It's sheetrock, and as you know, sheetrock is right now the most litigious material on the face of the planet. Literally, all of the houses in the United States are eating their own electrical wiring due to this sheetrock coming from somewhere else. So maybe next year it's sheetrock and plastic for one more time and get to sort of move down the line. Okay, so what is the theme this time around? Again, to Michael Bell, I think my personal gratitude and thanks for having framed this in a way that has us all wondering, all thinking, post-ductility. Ductility, of course, is the traditional limit of a material system. We are all trained to be a long way away from that limit. Architects don't know where the limit is, so often engineers have to point out where it is, and then everybody pulls back. So everybody's just a hell of a long way from the limit. The limit is sort of over there. It's a part of the beach you just don't go to. Of course, when engineers and architects start to dance together, the engineer starts to become the one who wants to kind of go closer to the limit, and the architect's saying, "Ooh, are you sure?" And new technologies, new analytical techniques, new fabrication techniques, and so on have changed even our perception of the limit. Limits multiply now. Limits are now time-specific, seasonal-specific. They also depend on multiple technologies. So basically there's an incredible sophistication of what constitutes the limit point of architecture. We are certainly operating way beyond what were normally regarded as the limits. And if in the past, the zone past ductility was a zone of very non-linear, a zone outside of control, we are now operating in that zone. And then the question for us is, are we now, as it were, swimming in a kind of non-linear, are we operating in an entirely different relationship to the material world due to our new abilities to monitor our own relationship to limits and the very question of limits? Or is it that the limits have just simply moved further down the track? Or it might be the view of some of the people in the conference that actually the limits are retrenching, and in fact, the more sophisticated we are with the precision with which we analyze the material world, perhaps the limits can actually come back towards us in a very, very interesting way. If you are working on questions of energy efficiency and sustainability and so on, that might be another way of describing what you're trying to do, which is to sort of pull the limit back towards what might be a doable normal practice and so on.